This is Geometry Section 6.6, Trapezoids and Kites, and I know how much you guys really appreciate some good math humor, so here goes. Hey, do geometry teachers have any special talents?
I hear they can fly kites well.
Okay, so let's begin by finding the definition of a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, so at our diagram on the right, we are going to label the parallel sides. Now the sides that are parallel, those are called our bases, which means the other two sides are called legs. And there are some specific or special trapezoids, and those are isosceles trapezoids. If you remember from talking about triangles, an isosceles triangle was a triangle with two congruent sides. So the definition of an isosceles trapezoid is a trapezoid with two congruent legs. Okay, so over here, these are our bases, and now these are congruent. Those are our congruent legs. And in isosceles trapezoid, you also have angles that have special properties. So, for instance, your two top base angles are the same measure, and your two bottom base angles are the same measure. Alright, so there's some other properties of an isosceles trapezoid. Well, we already talked about the angle, so we better write that down. Both pairs of base angles are congruent. And we marked them congruent in our picture, so now let's go ahead and state those angles. So it would be angle A is congruent to angle B, and the bottom base, or angle D, is congruent to angle C. Another property of an isosceles trapezoid is the diagonals are congruent. Okay, so the length from A to C is going to be the same as the length from B to D. Okay, so now let's talk about mid-segment theorem for trapezoids. And you may remember the mid-segment theorem for triangles, and that was that if you connected the two midpoints together of any two sides, it was called the mid-segment. So that definition still applies to trapezoids. It is a segment that connects the midpoints of the two legs. Okay, so let's go over here and label our trapezoid. We have A, B, C, D. And I'm just going to put where I think the midpoint might occur, right here, and right there. And if you remember, AB is parallel to DC. So that was the definition of a trapezoid. I'm now going to connect my midpoints together. Okay? And I want to show that it's a midpoint. I'm going to mark congruent lengths. Now there are some properties of midsegments. Because AB is parallel to DC, the first property is that the midsegment, and we'll go ahead and call it EF, will also be parallel. So in fact now all three segments are parallel to each other. So the first property, the midsegment is parallel to the bases. The second property, the length is half the sum of the lengths of the bases. So the length, and of course I'm referring to the midsegment, is half the length, or is half the sum, of the lengths of the bases. Now, an easier way to remember that might be that the length of the midsegment is the average of the bases. And if you remember how to calculate average, you add up all that you have and you divide by the number that you had, or the quantity. So here I'm going to add up the two lengths, and I always divide by 2. Okay, now let's move on to kites. And the definition of a kite is a quadrilateral in which both pairs of consecutive sides are congruent. Okay, what I mean by that is I'm going to go over here and I'm going to label my kite. I have A, B, C, and D. Side AB is congruent to AD. Those are consecutive, and those are the congruent ones. And then you have BC is congruent to DC. Okay, so one of the properties in a kite is diagonals are perpendicular. I'm going to go ahead and draw my diagonals, and then I want to mark them perpendicular. Okay, there's other special properties about kites involving their angles. For instance, because these diagonals are perpendicular, what it does is this angle here is going to be congruent to this part, and the other side of angle B is congruent to the other side of angle D. Okay? Alright, so we're going to start practice problem number 1. We have kite ABCD, and the measure of angle DAB is 54. So this whole angle is 54 degrees. And the measure of angle CDF is 52. We want to find the measure of angle BCD. This one right here. Sorry, this whole one. Okay. Well, if this part of angle D is 52, then this part of angle B is also going to be 52. If you remember from the previous slide, those angles will be congruent. Well, now you have this triangle, and you want to find that third angle in that triangle. So all you have to do is take 180, subtract 52 from it, or subtract the other 52, and whatever you have left over is going to be the measure of angle BCD. So that's going to be 76 degrees. Okay, now for B and C, we are actually going to finish this in class. Okay, if you want to, though, you're more than welcome to go ahead and start doing this. And if you get it done, bring it up to me and I'll give you extra credit for it. Okay, so moving on to practice problem number 2. We want to find the measure of angle A. And you first got to start by recognizing what kind of shape you have. You could say it's a trapezoid, but more specifically, it's an isosceles trapezoid because the two legs are marked congruent. And if you remember, the two base angles are going to be congruent to each other in an isosceles trapezoid. So angle C, which is 100, is congruent to angle D. So I'm going to mark 100 there. Also, this angle here is going to be congruent to that angle. And again, it's a quadrilateral, so all four angles should add up to 360 degrees. So I'm going to take 360, subtract each of those 100s, and I have 160 degrees left over. And that needs to be split between angle B and angle A. And since they're the same measure, all I have to do is take 160 divided by 2. And we get 80 degrees. So measure of angle A equals 80 degrees. Okay, number 4. Find the value of A so that PQRS is isosceles. Well, if you remember, the base angles, so meaning angle P, should be congruent to angle S. So all I need to do is take 2a squared minus 54, set it equal to a squared plus 27. And we go ahead and solve. We're going to subtract a squared over. Well, 2a squared minus 1a squared is just 1a squared. Minus 54 equals 27. So I'm going to add 54 to the right. And I get a squared is equal to 81. Okay, so I want to do the square root of 81. So a could be positive 9 or negative 9. Either one will work. Okay, practice problem number 5. It says find the length of EF. Well, EF is just a midsegment. And the length of the midsegment is an average of the length of your bases. So I want to find the average of 8 and 13.5. How do you find average? You add up the values that you have and then divide by those numbers. So I have 8 plus 13.5. And I have two numbers, so I'm going to divide by 2. We end up with E to F being the length of 10 and 75/100ths. Practice problem number 6, it says find the length of EH. Well, taking a look at the picture, EH is not the midsegment. I'm going to call this X. But they do give us the length of the midsegment. So you're going to write your formula as if you're finding this length of the midsegment. Well, how did we get that length? We took 25 plus X, and we always divided that by 2. Remember, we were just finding the average. And the average is 16.5. So now we have this equation that we're going to use to solve for X. And the first thing you got to do is get rid of that 2. So instead of dividing by 2, I'm going to multiply both sides by 2. So I have 25 plus X equals 33. And now all I have to do is subtract 25 over. So X is 8, which means the length of segment EH is 8 units. All right, have a great time. We'll see you in class tomorrow.